everyone, welcome to my channel. In today's session, I'll discuss about matrix multiplication. But before I begin with the today's topic, let's see answers of the problems given as exercise in the previous video. So these three problems were given as exercise and here are the answers. I hope you all must have got the right answer. And if you have any queries, let me know in the comment section. Those of you who have not seen that video, the link is given in the description. Do check. My previous video was on matrix addition, scalar multiplication, and matrix subtraction. Let's begin with the today's topic. That's multiplication of matrices or matrix multiplication. Let's see first condition to define matrix multiplication. The product AB of matrices A and B is defined if number of columns of A is equal to the number of rows of B. So this is the condition to define the product A into B. If you recall, there was condition to define A plus B as well. To define A plus B, both the matrices should have same order. Here it is not so. If you have two matrices of same order, then also the product may or may not be defined. Let's see how. So suppose if I take two matrices of order m by n, A of order m by n, matrix B of order m by n, and I take m not equals to n, number of rows not equals to number of columns, and I want to define this product A into B. To define product A into B, number of columns in first matrix, our first matrix is A, and number of columns in first matrix is n, must be equal to number of rows in second matrix. Our second matrix is B and number of rows is m, and we have m not equals to n, so the condition is not satisfied, so we can't define product A into B. A into B is not defined. So you all can see we have two matrices of same order, but the product is not defined. To define product AB, the condition given here must be satisfied. Number of columns in first matrix must be equal to number of rows in second matrix. Let's see the definition. So I have taken a matrix A of order m by n and matrix B of order n by p, and if you observe, you can see the condition to define product AB is satisfied over here. What is the condition? The condition is number of columns in first matrix. Our first matrix is A and number of columns is n, must be equal to number of rows in second matrix. Our second matrix is B and number of rows in B is n. You can see it's matching, it's equal. So A into B, the product A into B is defined. So what is written next? Then the product AB of matrices A and B is a matrix of order m by p. So if we have a matrix A of order m by n and matrix B of order n by p and it is matching, so product AB will be a matrix of order m by p. This n and this n will get cancelled. There will be number of rows m and there will be number of columns p in the product AB. So this was about order of the product AB. Let's see how matrix is defined, how the product is defined. So you all can see the product AB equals to, and inside a bracket the thing which you see, that is a general element of the product AB. The thing which you see in the bracket, that is ikth element of AB. This is ikth element of AB. What do you mean by ikth element? An element present in ith row and kth column. You all can see I have written Aij. Aij means element present in ith row, jth column. I have used here Bjk. Bjk means element present in jth row and kth column. So this I you can see is fixed. This k you can see is fixed. There is a j which is varying from 1 to n. How it works, how you are getting this, that I'm going to tell you in the next slide. Okay. So basically what happens whenever we define product AB, to get an element, we pick a row from A and we pick a column from B and we multiply them together to get an element in AB. For example, suppose I want element which is present in first row and second column. What I'm going to do, I'm going to pick first row of A and second column of B and I'm going to multiply them. That will give me element present in first row, second column. This index you have to understand. If I am saying x12, I am using this notation to denote element present in first row, second column of product AB. So this one means you have to pick first row of A. This 2 means you have to pick second column of B and you have to multiply them to get an element present in first row, second column. Okay. So here is your matrix A of order m by n. Here is your matrix B of order n by p. And here is your matrix AB of order m by p. This n and this n gets cancelled to give you product of order m by p. And this is your ikth element of product AB. Okay. So to get ikth element, what I said, you have to pick ith row of A and kth column of B. Ith row of A, kth column of B. You can see I have shown here ith row of K. Here is your ith row of K. And here is your kth column of B. What do you need to do after that? You have to multiply. Multiply means this first element AI1 multiply with B1K. This AI2 will multiply with this B2K. This AI3 will multiply with B3K. And like that, it will go up to the last element, that is AIN will multiply with BNK. You all can see the first index of this element is fixed. Everywhere it is I. But the second element is varying from 1 to n. Similarly, here in B, the second index k is fixed and the first index is varying from 1 to n. So that I am denoting by j over here. J is varying. J is the column index of A and j is the row index of B, which is varying from 1 to n. And what is happening between those elements? Those elements are multiplying. So you all can see there is a multiplication happening in those two elements. And what after multiplying the elements? The terms which we are getting after multiplication, that we add. So there is a summation sign. So nothing but AI1 multiplied with B1k plus AI2 multiplying with B2k plus, and like that you have to continue up to AIN multiplied with ANK. So I hope whatever is written inside this bracket must be clear. If it is not clear, let's see one small example to make it clear, to make it more clear. So let's take some examples, some small example. Let's start to understand matrix multiplication. So I have taken two matrices of order 2 by 2. Matrix A is of order 2 by 2, matrix B is of order 2 by 2, and we are defining product AB. And what will be the order of A into B? So this 2 and 2 will get cancelled. Order of A into B will be 2 by 2. Now let's talk about this first element. I have used notation Xij to represent element of AB. So to get this element, you have to concentrate on this row index and the column index. Remember, rows will always come from first matrix and columns will always come from second matrix. My first matrix is A and my second matrix is B. So rows will always come from matrix A and columns will always come from matrix B. Which row and which column, that depends on this index. Suppose I am talking about this x21. So row index is 2. So second row you have to pick. You have to pick second row of A. Means this. Column index is 1. So you have to pick first column of B. What to do next? You have to multiply them together. So this 5 multiplies with this 1 plus this 3 multiplies with this 2 to give you this. Suppose I'm talking about x to 2. So it's 2, row index is 2. Row index is 2 means you have to pick second row of A. Second row of A. Column index is 2. So means you have to pick second column and you have to multiply them together to get this x. I hope the idea is clear. Let's do it one by one. If at all not clear, it will be clear. So to make you understand nicely, I have used a red and green color combination over here. I have used red color for rows and green color for columns. And right now we are talking about the first element, that is x11. So in x11, 1 is the row index, and 1 is the row index means you have to pick row 1 of A. Row 1 of A is 2 1. You can see I have highlighted that by red color, and column index is 1. So you have to pick first column of B. You can see I have used green color to highlight that element in B. And what you need to do, you have to multiply this first row by first column to get this x11. So this 2 multiplies with 1, and this 1 multiplies with this 2, and you add them. 2 into 2, 2 into 1 is 2, 1 into 2 is 2, and 2 plus 2 is 4. So x11 becomes 4. Let's see the second element, x12. Index, row index is 1. So row 1 is selected. Column index is 2. So column 2 is selected. You have to multiply them. So this 2 multiplies with 3 plus 1 multiplies with 4. 2 into 3 is 6. 1 into 4 is 4. 6 plus 4 is 10. So your x12 is 10. Let's see the next one, which is x21. In x21, 2 is the row index. So you can see second row is highlighted over here. Column index is 1. So first column is highlighted over here, and you have to multiply them. Means 5 into 1 plus 3 into 2 to give you 11. And your next element is x22, second row. So you can see second row I have highlighted by red. Second column, you can see I have highlighted second column by red, and you have to multiply them. So 5 into 3 plus 3 into 4 to give you 27. So the product is 2 by 2 matrix with first row 410 and second row 1127. I hope the idea is clear now. What we need to do? We need to concentrate on the position. Position is 1 1 means first row you have to select from first matrix. First column you have to select from second matrix. You have to multiply them to get x12. Position is x12. So you'll select first row and second column to get x12. Position is x21. So you'll select second row, first column to get x21. Position is x22. So to get x22, you select second row and second column to get x22. Let's proceed to the next example. So I have a matrix here of order 2 by 2 and of order 2 by 3. If you check condition, number of columns in first is same as number of rows in second. So matrix multiplication, the product A into B is defined. And the product AB will have order 2 by 3. This 2 cancels with this 2. So what you left with? 2 by 3. So your product AB will have order 2 by 3 over here. So here is your matrix AB of order 2 by 3. Now let's see how to get these elements. Let's talk about this first one. This first one is present in first row, first column. So row index is 1. So you are going to pick first row of A. Column index is 1. So you are going to pick first column of B. And you will multiply them to get this first row, first element of product AB. See this. So this 2 multiplies with this minus 1. So this 2 multiplies with this minus 1 plus this minus 1 multiplies with this 8 to give you the first element. Okay. Let's talk about the second element. The second element is present at first row, second column. Row index is 1, so you'll pick first row of A. Column index is 2, so you'll pick second column of B. You'll multiply them to get this first row, second column of the product. Here you can see first row, second column multiplying. 2 multiplies with 2 plus minus 1 multiplies with 1 to give you second row, first column element. To give you first row, second column element. Let's talk about this third one. That is the element present in first row, third column. So you'll pick first row of A, and third column of B, and you'll multiply them to get this first row, third column element of AB. Here you can see. So you multiply this 2. So here you multiply this 2 by 4. 2 into 4 plus this minus 1 you multiply by 3 minus 1 into 3 to get element present in first row, third column. Next we have to get this element. This is present in second row, first column. So you'll pick second row of A and first column of B and you'll multiply them to get the second row, first column element of AB. Here you can see second row multiplying with first column, 4 multiplying with minus 1 plus 6 multiplying with 8. Let's talk about the next element. This is element present in second row, second column. So you'll pick second row of A. You'll pick second row of A and second column of B. You'll pick second column of B. You'll multiply them to get second row, second column element of product AB. Here you can see second row multiplying with second column to give you second row, second column element of AB. 4 multiplies with 2 plus 6 multiplies with 1 to give you second row, second column element of AB. The next element is present in second row, third column. Second row, so you'll pick second row of A. Third column, so you'll pick third column of B. You'll multiply to get second row, third column element of AB. Here you can see second row multiplying with second column. So 4 multiplies with 4, 4 into 4 plus 6 multiplies with 3, 6 into 3. So here is your A into B. I hope the matrix multiplication must be clear. Let's proceed next. So in this section, we are going to see how to compute powers of matrix. Nothing but a square, a cube, a raised to 4, or in general, a raised to n. Okay. So a square is nothing but if you multiply matrix A with itself, so that will give you a square. A cube is defined as multiplying a square matrix with A will give you a cube. In general, we can write this as a raised to n is equals to a raised to n minus 1 into a, where n is greater than equals to 2. Remember, this general formula is for n greater than or equals to 2. So if we put 2, this a raised to n becomes a square, and this a raised to n minus 1 becomes a into a, and you get this number 1. And if I put 3 in place of n, I get a raised to n equals to a square into a. Nothing but your point number 2. We can get a raised to 4, a raised to 5, whatever power is necessary. For example, if I want a raised to 7, so a raised to 7 will equals to a raised to 6 into a by using this formula. Let's see some example. So I have one 2 by 2 matrix over here, and I'm going to compute a square and a cube for this. A square is what? Matrix A multiplied with itself gives you a square. So you can see I'm multiplying A with itself to get a square. So to get first element of this a square, I have to multiply first row by first column. So here is your first row multiplying with first column. To get element present in first row, second column, I have to multiply first row with second column. So here we are multiplying first row by second column. To get element present in second row, first column, you have to pick second row and first column. You have to multiply them to get second row, first column element of a square. And like that, second row multiplies with second column to give you second row, second column of second row, second column element of a square. And here is your a square. Let's compute a cube now. To compute a cube, we need a and a square both. A cube is what? A square into a. So A square into A. So these two matrices you are going to multiply. I hope everybody is clear with the matrix multiplication. So I request you to pause the video and do this matrix multiplication on your own, and we will check. I hope you all must have got this answer. Okay. Now let's proceed to the next. In this section of the video, we are going to see 6 very important properties of matrix multiplication. But before that, this very important point which you should note: all matrices taken are conformable with respect to the operations. What it means? The meaning of this statement is, if you come across somewhere, let's say A plus B, so matrix must be taken in a such a way that this A plus B is defined. If somewhere you are coming across AB, so matrices must be taken in a such a way that this A into B is defined. I will also would like to highlight over here, you'll come across one property, existence of identity, existence of multiplicative identity. There I have written I into A equals to A into I equals to A. So here, if your matrix A is of order m by n, and I am writing I into A, so in that case, this I is nothing but Im. Im means identity matrix of order m, and this multiplying together to give you A. And if I am writing A into I, A is of order m by n, so this I must be of order n, identity matrix of order n, to give you A. So this I, this I and this I may or may not be same. If I am taking square matrix of order n, so this I must be In, this I must be In, so they are same. But if I am taking a general matrix of order m by n, so this I and this I is not same. This first I is Im and this second I is In. They are not same. So this thing must be clear in everybody's mind. Let's see the properties. Here is your property number 1. AB not equals to BA. Matrix multiplication is not commutative. This property is very important and very useful. If you recall, your matrix addition is commutative. Your A plus B is equals to B plus A. And what it means? Order does not matter whether we add A with B or we add B with A. It doesn't matter. But here the matrix multiplication is not commutative. So it means whether we multiply A by B or we multiply B by A, it's not same. It may give you different answer. AB may or may not equal to BA. Let's see some example. We are going to see two examples over here. In one example, AB will equals to BA, and in another example, AB not equals to BA. Here is your example number 1. I have taken two matrices of order 2 by 2, and I suggest you to pause the video and compute the product AB and BA. I hope you all must have got this. I'm getting this AB is equals to matrix with first row 117, second row 515, and matrix BA as first row 610 and second row 1310. And you all can observe here this AB is not equals to BA. Let's see another example. So here is your matrix A and matrix B, and I again request you to pause the video and to compute AB and BA. I hope you all must have got this answer, and if you compare AB and BA, both the matrices are equal. So actually what I mean to say over here, whenever somebody gives you a particular matrix, somebody give you matrix A as something, matrix B as something, and ask you whether AB is equals to BA or not. By using the property, you can't bluntly say AB is not equals to BA. You need to check there whether AB is not equals to BA or AB equals to BA. And if somebody is asking you in general, is AB is equals to BA? So you can say no, AB is not equals to BA. Okay, the two things are very different. If there is a particular matrix with you, you can't say directly AB is not equals to BA by using this property. You need to check AB is what and BA is what, are they same or not. Then only you can conclude. But in general, if we say is AB equals to BA, so we can say AB is not equals to BA. Matrix multiplication is not commutative. Let's see the second property. This is associative law of matrix multiplication. What we have here, if you concentrate on the left side, A into B into C means you are multiplying AB first, and whatever is the result that you are multiplying with C. Whereas in RHS, you are multiplying BC first, and whatever is the result you are multiplying with A. A multiplied with the result. Okay. So matrix multiplication is associative. What is the benefit of this? The benefit is whenever you have more than two matrices multiplying, there is no meaning of brackets. Whatever you are comfortable, you can pick two of them. Obviously, the two matrices has to be consecutive, should be next to each other, and after that you can proceed with the multiplication. For example, suppose I have matrix A, B, C, D multiplying together. So I need not worry about which matrix to multiply first. What I can do, I can multiply this AB first. Let's say I'm getting some matrix P after multiplication. So I get PCD after that. And after that, I can multiply this C and D first. I can multiply this C and D next. Suppose I get matrix Q as result. And after that, I can multiply this PQ to get the result. I can even do this A into B into C into D as, suppose I multiply this B into C first. B into C results into matrix P to give you this. And after that, I can do this P into D, which gives you Q, and you get AQ. And you multiply this AQ after that, that gives you result R. So this R which you are getting here and this R which you are getting here will be same. Both will be equal. And that is happening because of this associative property. I hope the importance and the idea is clear. Let's see the next. So here is your next property, existence of multiplicative identity I. This I is nothing but your identity matrix I. I hope you all remember what is identity matrix I, right? So what is the importance of this property? If we multiply any matrix A with identity matrix, there won't be any change. It will remain as it is. A into I or I into A will equals to A. Okay, let's see the next. Here is the property number 4, distributive law. This is very important property. What is happening in this property? We are distributing matrix multiplication over matrix addition. And there are two laws over here. One is happening from the left side. You all can see this matrix multiplication is multiplying. That term is on the left side. We also call it as pre-multiplication. And in the second law, the multiplication term, that is C, is on the right side. We call it as post multiplication. Pre multiplication and post multiplication are two different things. Okay, and that is two different things because of that non-commutative property of matrix multiplication. Okay, so if we have A into B plus C, so what we can do, this A multiplies with B to give you AB, and then this matrix addition, then this A multiplies with this C to give you this AC. And in the second distributive law, this C is multiplying from the right side. So this C multiplies with this A to give you AC, then this matrix addition plus, which is here, and then this C multiplies with this B to give you BC. Okay, so matrix multiplication distribute over matrix addition from both the sides, left side as well as right side, from pre as well as from post. Okay, let's see the next property. This is very important property. Everybody need to understand this property very well. Your property number 5 is what? If AB equals to 0, then we can't imply from that A is equals to 0 or B is equals to 0. What I want to say over here, we have many a times used in mathematics, whenever we come across this x into y equals to 0, we write after that x equals to 0 or y equals to 0, right? But this does not hold in matrix multiplication. If we have two matrices multiplying together to give you 0, we can't conclude from there A is equals to 0 or B is equals to 0. We can't conclude this. AB equals to 0 does not imply A is equals to 0 or B is equals to 0. Okay? Let's say example to understand this. So here I have two matrices A and B, and I again suggest you all to pause the video and to compute AB. I hope you all must have got this AB. Okay. So what I want to say over here, I want to say we have this A which is non-zero. We have this B which is non-zero. Both are non-zero, but their product is 0. So we have what? We have AB equals to 0, but neither A equals to 0 nor B equals to 0. I hope the idea is clear. The idea is whenever you have product of matrices equals to 0, you can't say from there that one of them is 0. You can have all non-zero, but the product is 0. Okay, I hope the idea is clear. Let's see the next. Here is the next property, which is again very important. If we have product AB equals to 0, that doesn't imply BA will also equals to 0. If two matrices multiplying together to give you product AB 0, then from there we can't conclude the product BA will also equals to 0. BA may or may not equals to 0. Let's see example to understand this. I have taken the same example. I have taken same matrix A and B. AB you have already calculated. Calculate BA. So here is your AB and BA. You all can see in this case AB is 0 but BA is non-zero. So what we have? We have two matrices such that the product AB is 0 but the product BA is non-zero. Okay. This property 6 is also very important. Everybody should have this in their mind. Let's proceed to the next. Okay. So here in this section we will discuss what will be A plus B whole square. Can you guess what will be A plus B whole square? If you are guessing, A plus B whole square equals to A square plus 2 times AB plus B square, then your guess is wrong. It doesn't hold in matrices. Let's see what happens in matrices. I'm going to tell you in depth, step by step. So here is your step number 1. A plus B whole square is equals to A plus B into A plus. Nothing but over here, I'm using power of matrices concept. Your x square is what? Your x square is x into x. So just assume this n plus b is x. So this becomes x square. So x square is what? X into x. So you have x into x over here. And what after that? This first a plus b, let it be a plus b. And this second a plus b, you assume as x. Okay? Nothing but I am telling you to consider this as a plus b like this. And the next bracket I am telling you to treat as x. And if you see, this is post multiplication of x. So you can apply the distributive law. So this x will multiply with a to give you ax, and this b multiply with this x to give you bx. Okay? Okay? So let's see the next step. Here it is. So here is your a, here is your a. Here is your x is a plus b, so here is your x, plus b, b, x, your x is a plus b, a plus b. And again, in the first term and in the second term, you are going to apply again the distributive property. So this a multiplies with this a to give you a into a into a is a square, then plus this a multiplies with this b to give you a into b, then this plus, then this b multiplies with this a to give you ba, and then plus this b multiplies with this b to give you b into b, that's b square. And after that, since this AB and BA are different because matrix multiplication is not commutative, we can't add them to give 2 times AB. So A plus B whole square is A square plus AB plus BA plus B square. It is not A square plus 2AB plus BA. I hope the idea is clear. Let's go next. So here is the exercise which you are going to solve. And here is one very important note point. Examples to be given other than discussed in the session. Nothing but there are some problems based on example. Nothing but you have to produce example over there. So you are going to produce your own example. You are not going to give example which is already discussed in the session. Okay. So here is problem 1, problem 2. So here I would like to discuss this problem number 2 a little bit. I am going to answer this question. Is AB equals to BA? Okay. So without computing also I can tell you whether AB equals to BA or not. So for that I want order of matrix A. What is the order of matrix A? The order is 3 by 1. And what is order of matrix B? Matrix B has order 1 by 3. There is one row and there are 3 columns. So if I'm talking about, AB. So AB, so you can see this 1 matches with this 1. So it will get cancelled. So you get AB order as 3 by 3. If I talk about BA, So for BA, you'll write like this: B first and A after that. A is 3 by 1. This 3 matches with this 3 and will get cancelled. So give you 1 by 1. So BA is the matrix of order 1 by 1. AB is matrix of order 3 by 3. You can see the order of the two matrices are different. And once the order is different, obviously they are not going to be same. We can't talk about equality then. Okay. But in problem number 2, it is asked to compute. So you are going to compute both. You are going to compute AB, you are going to compute BA, and after that you are going to answer this. Is AB equals to BA? And answer for that part is no. AB is not equals to BA. Clear? Here is your problem number 3 and problem number 4. Problem number 5, 6 and 7. Okay. So I hope you all must have understood how to multiply the matrices and the properties which I taught you. Don't forget to like if you like the video, comment, share and subscribe to my channel if you haven't subscribed yet. Thanks for watching.